All right, so as we enter week 2, we're going to start with some division, and we're going to throw like a little bit of a kickback way back to 3rd and 4th grade where we did some long division. Now we are going to apply it to what we're doing in this unit, but we are going to start by doing long division by hand. So we're not going to use a calculator per se to come up with the answer. I know that that's there and a good resource, but we want to review the process of long division because it's the process that we're going to use when we long divide polynomials. So here's a copy of our note sheet up here in the top box. I'm going to write, long division. To be a little more specific, it's long division of polynomials. But like I said, we are going to start with regular old long division, okay? So let's begin with that, long division. Well, what is long division? Let's think back in our brain, back to 3rd and 4th grade when we learned this the first time. Long division is the process of determining, this is probably how you learned it way back then, how many times a divisor goes into a number called the dividend. Okay, so if we look down here at our problem, 3 is our divisor. We want to know how many times 3 goes into the dividend, which is, let's get this number, 42,186,307. So we want to figure out how many times 3 goes into that number. Now we're going to change that slightly. How many times it goes into something is a great way of thinking about division, but we're going to actually shift it a little bit. Like I said, we're going to say, well, which is our answer, what times the divisor gives us the dividend. So I'm going to make a note of that out here to the side. Change my color again. I'm going to use blue. So this is how we want to be thinking about it for polynomials. What times the divisor gives, either one, the dividend. Remember, multiplication and division are inverse operations. So yes, how many times we're dividing 3 into the dividend, but we can think of it as our answer times our divisor should give us the dividend. And that's really what we want to be thinking about for polynomials. We're going to review this process though here, long division from 3rd grade. I say 3rd grade, that's when I learned it. You guys might have learned it earlier or later, just kind of depends on what your school did. But what we did is we looked at 3 and we said, well, how many times does 3 go into 4? 1 time. 1 times 3 is 3. 4 minus 3, and then we subtract it here, is 1, and then we bring down that next number. If we had a number here that 3 went into, that tells us we didn't take as many out as we needed to up here for our answer. This time, how many times does 3 go into 12? Well, the answer is 4, and 3 times 4 is 12, and we subtract, and we get 0. And then we bring down that next number. 3 does not go into 1, so I put a 0 up here, and then I bring down the next number. I bring down 8. How many times does 3 go into 18? The answer is 6. 3 times 6 is 18, and we subtract, and we get another 0. I bring down the next number, 6. 3 goes into 6 twice. These are nice numbers because they all go in evenly. Bring down a 3. 3 goes into 3 once. 3 times 1 is 3. Subtract that, gets 0. Bring down our next 0. 0 does not go into 0, so I put a 0 here. Bring down the 7. How many times does 3 go into 7? Well, the answer is twice. And I'm running out of room, so I'm going to put it up here. 3 times 2 is 6. And I subtract, and I get a 1. And that's, I'm out of numbers here. I'm out of stuff. Now, we're going to write it a little differently than what you did in 3rd grade. We used to write R1, remainder 1, but really what that is all of those numbers, and it's going to take me a second to figure out what that is. Let's see, that is 14,062,102 and 1/3. We take our remainder over the divisor. It is part of a whole. I have one of the 3 that I need to make that go in evenly, and I don't have a full thing, so I make it 1/3. And this is how we're going to write, I've lost my cursor, this is how we're going to write our answers today, okay, for polynomials. Now, Again, back in the day, you wrote remainder 1. You could have carried that out with decimal places and done the same thing and gone out and got a decimal, but we're not doing that. We're going to do 1/3. Okay? So remember that. Remember that process because that's how we're going to do polynomials. And then the rest of this is all examples. Okay? So we're going to start out with an example of a polynomial here. We have our divisor of x minus 1 and our dividend of x cubed plus 2x squared minus x minus 2. So we want to start with these things out in front. And like I said, we're going to shift it slightly. I'm not going to say, well, how many times does x go into x cubed? I want to be thinking as what, which is going to take this place up here at the top. What times x gives me x cubed? And that answer is x squared. Okay? And then I can do this in my head. I'm going to show this step out to the side. But just like we did with long division earlier, we take what we wrote up here up top for our answer and multiply it by our divisor. So I'm going to do x squared times x minus 1, which gives me x cubed minus x squared. Okay, really you're distributing it. You don't have to show me this. You can do that in your head. But we draw a line and we're going to subtract just like we did earlier. But when we subtract, you have to distribute that negative sign. This would be a good idea to change colors here. You have to distribute that negative sign through to both terms. So it becomes, this cancels out. This becomes 0, which is what we want. We want it to go away. And then over here we have 3x squared. And we bring down our next term and we repeat that process. Well, what times x gives me 3x squared? What times x gives me 3x squared? And the answer is 3x. Now I'm going to do 3x times x minus 1. And again, you can do this in your head. That gives us 3x squared minus 3x. You want to subtract here, which means you're going to distribute a negative through the bottom. These cancel, which is what we want. We're left with 2x, and then you bring down the next term, minus 2. Well, what times x gives us x squared? We're looking at those first terms again. What times x gives us, 2x, not x squared, 2x, and the answer is 2. So in our head or out to the side, however you feel like you want to do it, 2 times x is 2x. 2 times negative 1 is negative 2. We are going to distribute a negative through because we're subtracting, which is what we did in the first video. We looked at that. And that gives us 0. Okay, when we were working with polynomials, it gives us 0. So I would have technically remainder 0 or 0 over my divisor. 0 in the numerator doesn't matter. This all goes away. So that's not pertinent to this problem. But our answer here is x squared plus 3x plus 2. Now this answer has a name. It's called a depressed polynomial. Okay, and this only called this for polynomials. It's not called a depressed answer for regular old long division, but it's a depressed polynomial here because it's 1 degree less than what we started with. It's depressed, it's smaller. Okay, now I want you to be thinking about that multiplication idea again. If we did x minus 1, our divisor, times our answer we got, what we should get is the dividend. Okay, and that's how we want to be thinking about long division. We don't want to be thinking about this divided into that. We want to be thinking about what can my answer be? What is my answer so that when I multiply it by my divisor, I get my dividend. And that's going to help us get through this. Okay, but that's our answer, x squared plus 3x plus 2. Now, the rest of these examples are all the same idea. They're all just presented slightly differently because division has a lot of ways it can be written. So this is another example here. And I am not going to work them all out. They are all worked out on the teacher copy of the notes, so feel free. I just want to show you how to set these up, and I will work a few out, but I'm not going to work them all out, okay? This particular one I'm just going to set up. Okay, when we look at it like this, I've lost my cursor, there it is. It is x cubed minus x squared plus 4x minus 10 divided by this here. This is my divisor. And then this is my dividend. Okay, so I put x plus 2 on the outside. And then I have x cubed minus x squared plus 4x minus 10. And I'd go through that same process we just did on that last example. Okay, again, I'm not working this particular one out. I just want to show you how to set it up. Another way that these can be written, instead of saying divided, it could have just a colon here, which means the same thing, that this is your dividend and this is your divisor. Again, I'm not going to work this one out fully. I'm just going to set it up. So I'd have x minus 5 in my division bar table, 2x cubed minus 5x squared minus 28x plus 15. And we'd go through that process for long division again. What up here times x gives me 2x cubed, and continue that process throughout. The next one I am going to work out. Okay, the next one's written as a fraction, and I noticed something here. I noticed when I look at the numerator, the other ones have all gone x cubed, x squared, x, and then the constant. This one does not. This goes x cubed and then x. This one's missing that x squared term, which is why I want to work this one out. Okay, but the top is my dividend, and the bottom is my divisor. So I'm going to have x plus 3 out in front, my division table bar thing, 2x cubed, and I do have to have an x squared term, so I'm going to put plus 0x squared. 0 times anything is 0, so this is just showing, it's basically a placeholder that it's there, but it's not changing the value of the problem. I've just rewritten it, okay, with the 0 in there for that term. I'm going to change colors as I work this out. So our first part here, what up here up top times x gives us 2x cubed, and the answer is 2x squared. So again, you can do this part in your head, that 2x squared times the x plus 3. That gives us 2x cubed plus 6x squared. And this is why we needed that placeholder, so that these, when I subtract, I have something to subtract it from. Okay? It's just helping me line up my work, all my numbers. Let's switch to a different color. Blue. So when we subtract, we have to distribute that negative through, and these cancel. That's what we want to happen. We get negative 6x squared and bring down the next term, minus 8x. So now what, up here up top, times x gives us negative 6x squared, and the answer is negative 6x. Again, you can do this part in your head or write it out to the side if you need to. Well, negative 6x times x is negative 6x squared, and then negative 6x times 3 would be negative 18x. I'm going to subtract, which means I have to distribute that negative through, which makes this plus and plus. Okay, so really I'm adding these now, and these cancel, and we get 10x. Bring down the next term, plus 5. Well, what times x gives me 10x? And the answer is 10. Okay, so plus 10. You do this in your head again. 10 times x plus 3. So 10x plus 30. I got a little sloppy writing there. We're going to subtract, so we have to distribute that negative through again. Minus, these cancel, that's what we want. We get negative 25. Now this is my remainder. This is important, okay? Remember, we don't write remainder r 25. No, we don't do this, okay? What we do is we say plus 25 over r divisor. Okay, we add it to it. Oh, sorry, plus negative 25. Now, I write plus and then the negative number on top. You could say minus 25 over x plus 3. It's also the same thing. You've just pulled that negative sign out in front. But you could always do plus and then your remainder on top. Either one is fine. So our answer to this problem is 2x squared minus 6x plus 10, and then either plus negative 25 over x plus 3, or, like I said, you could do 2x squared minus 6x plus 10 minus, and then a positive 25 over x plus 3, pulling that negative on the 25 out in front. Either one of these would be an acceptable answer here. Okay. Now again, these are the depressed polynomials. Okay, because they are less than what we started with, our divisor. That's what we would multiply our divisor by to get our dividend. Okay, so a couple things about this problem before we move on to the next example. Number one, it's written as a fraction, not anything different. It's a representation you can see. The second thing is you need a placeholder there because you are missing a term. You're missing that x squared. Okay, so make sure you add that in before you start doing long division. And the final thing to this one is that it had a remainder. When you have that remainder, make sure you put it out to the end over the divisor, just like we did for the 1/3 on the example we did when we started. Okay, it's really plus 1/3 to that number. We're adding a 1/3 to it. Here we're adding negative 25 over our divisor, x plus 3. Okay, so that's this example. Now we do have one more. This one's the directions are slightly different here. It says determine all the factors and roots of the polynomial. So the setup on this one's going to be the same as it was earlier when I showed you the problem with the semicolon. What's going to be different is our answer. You're going to present it two different ways. We're looking for two different things here, the factors and the roots. So we're going to start with 2x minus 1, that's our divisor. Out in front, 2x cubed minus 7x squared minus 53x minus 28. Now on this particular one, no placeholders needed because we have all of the terms. The cube, the square, the x, and the constant. So we need to be thinking of what times 2x gives us 2x cubed, and that's going to be x squared. And I'm actually going to write this out over to this side. So x squared times 2x minus 1 is really 2x cubed minus x squared. But we're going to subtract, so we have to distribute that negative through the second one here. So minus, and that changes that to a plus. These cancel, and we have negative 6x squared. Bring down the next term, minus 53x. Now we repeat that process again. What times 2x gives us negative 6x squared? And the answer is negative 3x. So I'm going to write it out over to the side again. You can do it in your head. 2x minus 1 gives us negative 6x squared plus 3x. Now, I don't think I've done a good job explaining up to this point why we want, why we do what times the first term gives us the term we have there, the 2x cubed or the negative 6x squared. The reason is we want it to cancel. When we distribute this negative through, okay, what we want to happen, signs change. We want that first term to cancel. We want it to go away. We want it to go in, the 2x to go evenly into what we have there. So we want it to match up. And that's why I want you to be thinking about that multiplication idea. What times 2x gives me what I'm looking for, okay? This ends up being negative 56x minus 28. Again, we were going to do what times 2x gives us negative 56, so that when we distribute the negative through, it becomes a positive 56, and we will cancel. That's what we want to see. And the answer here is a negative 28. Okay, I'm going to write it out to the side here. Negative 28 times 2x minus 1. Well, that gives us negative 56. Like I said, that's what we want. Plus 28x. When we change our signs, change my color here real quick. Distribute. Okay, these cancel. We want 0. Now, I've noticed something here, and you're going to have to go through and change this. I have made a typo on this particular problem. We want this to be a positive. The intent of this problem is for us to find factors and roots. So I want it to come out evenly. This is a mistake on my part. So I do want you to fix the problem. Okay, fix this problem. Change this to a positive, which means throughout your problem, this should be a plus 28, this should be a plus 28. Okay, this can still be minus 28 here, that's what we want, but what I want to happen is there to be no remainder. Okay, so that's an issue on my end. Be sure that you fix that mistake right here, and I'll make a note of it in the video as well. Okay, so, or in the description of the video. So negative 28. Now, we have x squared minus 3x minus 28. That's our depressed polynomial. I don't want to stop there though. I says what I want all the factors. So we're going to factor this. Okay. X. I need two things that will multiply to negative 28 but add to negative 3. And those things are going to be negative 7 and 4. Now I get to jump right in and use that shortcut because the a value is 1. So what we have now, 2x minus 1, x minus 7, and x plus 4. These are my factors. Okay, so that checks off this. Okay, I'm going to make a note over here by my depressed polynomial that we need to factor it. And we only need to factor it here when it asks for all the factors. Okay, so that's the first part. It also says we want all the roots. So really what we're going to do is we're going to take each one of these and set them equal to 0. Okay, and we get 1/2, 7, and negative 4. I'm going to list those out numerically. And here are my roots. Okay, so we're using the zero product property there to actually find the roots. And that's considered solving, and that's where we're heading. I'm having you do it on this particular one because that's where we're heading towards the end of the week here, looking at using this idea to solve a polynomial. Okay, so there we go, and that's what we've done. So if it's kind of tricky on this one, I could ask you for several things. I could ask you for all the factors, which is what we found here. Went ahead and factored that depressed polynomial. I could just ask you for the depressed polynomial. I could ask you for the roots. Could ask you for the remainder. So this process has a lot of different questions that could be asked of it and different things that you could give me. So it's really important you know it inside and out. The same can be said for synthetic division, which is the next video. Lots of other things that could be asked. Okay? So here's what I need you to do. I need you to fill in that summary, recap, next step sections of your notes, post that to the discussion board. Be sure to go back and look at those examples that I just set up and didn't work fully through. If you need some more practice, try them on your own and check them against the teacher copy of the notes. This practice is paired with the synthetic division practice in the video that goes along with that. So the 5 questions I want you to complete for this video are, the note sheet is divided into 2 page sections. So the part that says page 124, I want you to do 6, 10, 22, 30, and 36, and use long division to do those problems, okay? Whether it says to in the directions or not. All right, if you got questions, please let me know. That's your video on long division.